Welcome to No Diagnostic Required, a monthly look at what's happening in the C++ community. With me, Phil Nash, and my co-host, as ever, Anastasia Kozakova. So, Anastasia, how are you doing this month?
Good. Mostly busy with the work, but I will talk about that later.
Oh yeah, not gone in this month, has it?
No.
Okay, well, I'm actually a little bit less stressed than usual because all the building work we've been having going on in the house is finally finished. After 6 months,
Yeah, congrats.
I'm actually enjoying a bit of peace and quiet. Not quite got my office studio built out yet, but it's getting there. So I'm gonna jump straight into it because we've got a lot to get through today. So I'm gonna leave you with the first one to talk through because that's the JetBrains State of the Developer Ecosystem 2021 report. What can you tell us about this?
Yeah, thank you, Phil. That's one of the things I was busy actually this month a lot. So this month we finally published the Developer Ecosystem 2021 report. It brings infographics based on the survey data, which we previously did like earlier this year. And there are many interesting observations for C++. And I actually did a blog post where I covered the most interesting highlights. And also there are some comments from Matt Godbolt, the creator of Compiler Explorer, and Andreas Klink, the creator of Serenity OS. Big thanks to Matt and Andreas for sharing their efforts on the data. So, and if you go for the data, I would like maybe to share just a few interesting highlights here.
Yeah.
So, the first one, and probably the biggest one, is that nearly 1 of 5 developers, so it's 18%, nearly 20, a little bit less, they're actually using C++ 20. Even though major compilers are still very slowly adopting this, big C++ release. So GCC is a little bit better, is a little bit behind, but still approaching. But yeah, it's great to see that it was beginning of the year and 18% were saying that they're using C++ 20. And talking about the exact features from the C++ 20, we asked about the models, the concept, and the coroutines. And they were the biggest feature of these 3 was modulus, actually 48%. So nearly half of the respondents were planning to adopt modulus in the next 12 months. So during the next year, they're going to start using modulus. Concepts are actually quite close. It's a choice for 46%, which is also great. So, and I would say that all big features are having big numbers there. So that means that the release is really pretty much attractive for the C++ developers. From the set points, they're the still a third of developers who are not writing any unit tests at all. And we were kind of disappointed there with this fact together with Matt. There is still a Google test, quite popular framework. There is Catch. I think Phil should be quite happy with Catch on the second place. It's something like 32% for the Google test and 11% Catch. Yeah, catching up quite quickly, I would say. So the second place and very strong second place here. Yeah, but still, 30% say that they don't write unit tests for C++. So maybe they do something different. I mean, some other kind of tests or whatever, but it still looks very strange to all of us. And many competing solutions for package management problem, but that's, I guess, a usual thing for C++. But again, a little bit disappointing fact that still manually bringing the library source code to the project is trending for 26% of the respondents. So most of us are still doing all these things manually, not relying on any package manager. This is a little bit sad, but I guess that's how it is right now. Top 3 project models stayed kind of unchanged. So it's CMake, Makefile, and Visual Studio. The order was a little bit changed. So CMake is still on top, but Makefiles and Visual Studio kind of swapped. That might be just, a matter of our data. So because they're very, very close. So, but still the top 3 is way different in numbers from all the others. And actually, C++ Foundation Light Survey, which we validated our data against, they have the same top 3. And actually, in my blog post, I highlighted the major similarities and differences with the foundation research. So if you're interested in how our data compares to foundation data. So you can find the answer in the blog post. So yeah, I don't think I will continue here because the report is huge. We can dedicate, I guess, the whole edition of our podcast to that. I was just maybe wondering to ask you, Phil, what was the most interesting fact maybe you found in there, or was it all normal?
Lots of interesting stuff, but the one that really stood out for me was the number of people looking to use modules in the near future. I think we said a few times on this show before that we're sort of considering modules more of a C++ 23 feature, not because that's when it will be ready in the standard, but I think because that's when the tooling may be ready. At the moment, I think it's only Visual Studio that even claims to be feature complete on the just the C++ side of it, let alone the tooling. So yeah, still a lot of work to be done before we can really start using it in most projects. But very interested to see so many people wanting to use it so soon. So let's hope that comes together. I think we're going to come back to modules a little bit later in the standards news section as well. There's still more work to be done there as well. But yeah, that really struck me. Such a high number of people wanting to use that in the near future.
Yeah, the committee definitely have to, help these 48% going to adopt the models, as well as the tool vendors. Yeah, that's true.
We definitely need it. That's for sure.
Yeah, agree. Okay, let's move forward.
Absolutely. So this one, sanitizers.
Yeah, I guess sanitizers are a very hot topic right now in the community. I see quite many people talking about them. This blog post is a little bit maybe basic. I mean, it explains some basic stuff, but still very, very useful. So if you're not using any sanitizers, this might be a good article to start your journey. So it actually explains 3 types of sanitizers: the address sanitizer, memory sanitizer, and undefined behavior sanitizer. So there's some short explanation on how they work and which issues they're capable of catching. And also the article actually estimates the CPU and memory overhead for these sanitizers, which is always good to understand how much you would pay for that. For address sanitizer, the article presents kind of very nice visualization with these so-called red zones around each set of bytes allocated with the malloc function. So you can just imagine how it works. I won't go into the details of how it works right now, but I want just to mention that there is 2x boost performance-wise and on memory usage. So it's just 2 times worse than the regular run if you compare the sanitizer run and the regular run. So for memory sanitizer, it's actually used to detect uses of uninitialized memory. So and it uses the approach of bit shadow mapping. I actually personally digged into the Google's paper about that from Evgeny Stepanov and Konstantin Serebryny. I guess Kostya was doing some talks on that quite often. Maybe at CPPCon even, I don't remember exactly. Live CPPCon for me was so long time ago. But I remember him speaking about these things. And yeah, the algorithm is actually very interesting. So the original Google paper is very interesting if you're, would like to learn these details deeper and understand how it works and the approach exactly. But yeah, just the fact is that the CPU overhead is 2.5x and memory overhead is just 2x. So it's not that big, I would say. So again, similar kind of numbers to address sanitizer. And undefined behavior sanitizer, that's actually, I would say, the most awesome thing I've ever met for C++ checks in that sense, because it can actually catch all these, not all, but quite many cases of this undefined behavior, which is a real pain point for C++ developers, as we see from Foundation survey, for example, that these undefined behavior issues, they are causing the real pains for C++ developers. And the sanitizer has all these nice flags, so you can actually check for some specific issues which you would expect in your code or which you would like to catch, like integer divide by 0 or assigned integer overflow. So you can pass some specific flags what to catch. And yeah, so it's definitely no memory impact on the memory usage, and the CPU is just 1.25x from the article. So anyway, it's all not that big. I mean, with the Valgrind, for example, you get a bigger overhead in CPU. Usually you don't need to recompile, which could cost you something. I mean, for sanitizers, that's a compiler flag, so you have to pass them and you have to recompile the code. which could actually, take some time. Let's call it this way. So, but the Valgrind actually saves you this time, but then it has a much bigger overhead in terms of the CPU compared to Sanitizers. So that's like the huge difference. So yeah, anyway, if you would like to check more details to see some examples and this nice visualization to see how it works, just check the article, check it out. It's really very nicely written. And yeah, I think, Phil, would you like to add something here?
Yeah, I was just going to say, I think if you're not using sanitizers for any serious work, you're really missing out on a huge boost to your ability to catch these things, which is almost impossible without them with modern C++ on any sort of size project. And most people are not going to be running the sanitizers in production, so those slowdowns are not usually going to be a problem. But if they really are, then you'll know that. But for most people, that's not going to be an issue. Just use them.
Yeah. Yeah. Okay, let's move forward and talk about the concepts. Actually, just a small remark. This month was a little bit tough because the most interesting articles were actually coming by the end of the month. I spotted this article from Jonathan just, while I was preparing the news, and I found it really, really very interesting. So it talks about the concepts. And like, as you remember, the concepts, this is the feature from C++20, which 46% of the respondents for our survey were gonna adopt during the next 12 months. Mm-hmm. So yeah, it's highly promoted right now in the C++ community, and there are many guidelines right now promoting the concept usage. And so Jonathan actually wrote a blog post comparing nominal and structural concepts. And this is a very interesting thing to understand about the concept and about how they are done in other languages. So I would like to highlight the biggest outcome of the whole article is that if you want to distinguish between identical syntax with different semantics, you need to introduce some syntax to distinguish it. I think that's just, that sounds great to me, but actually that's really very true. So the general idea here is that in case of structural typing, like a type models the concept if it has some same structure as the one required by the concept. And this is how we do. And this also means that the naming is really important. So you have to match the names. And there is a very funny example in the article from Jonathan about the t-shirt class, which actually passes the semantic checks for stud vector. And this illustrates the whole problem with this, no semantics by just, matching the names, matching the structure. So definitely t-shirt has nothing in common with stud vector. But it actually, it passes all the checks. So yeah, why not? In other languages where the concepts were kind of introduced from the very beginning, because the languages are quite young, the model, to model a concept, developer has to actually state it explicitly. So you need to actually opt in. You definitely can do that with, 30-year-old C++ code. So we don't have this benefit just because we have huge code bases which are created many years ago. But it's just good to understand all these concepts of opt-in and opt-out for the concept model, and that C++ actually can't afford this opt-in approach, I guess. And so, yeah, that's just an interesting fact to understand about the concept and how they differ from what the other languages have and what they can actually afford. So I don't know what you feel here.
Yeah, I like to think of concepts as static duck typing. If it quacks like a duck _v, if you like.
Yeah.
So it's more about what it can do rather than exactly how it's laid out. So it's there are some downsides to that. I'm not sure if the article goes into that because I didn't read it in full, but mostly it's upside. So we even have a better facility there than Rust in most respects. That's not something we can usually say these days, but there we go.
Yeah.
Okay, so next, counting in iteration models.
Yeah, let's iterate to iterators a little bit and talk about them for a while. So this one is from Barry Revson, who actually did a talk on iteration models of several different languages at C++ Now online this year. And now he did a blog post where he actually ungrouped the languages he was grouping in his talk. So they're like C++ D against C# iterators model, which he was like putting in one group in his talk, but he's now like trying to ungroup here in this blog post. And he mentioned this proposal, like P2406, which highlights this like a little bit weird issue that counted iterator actually increments its internal iterator even when reaching its own end. So I guess the committee needs to somehow address this, and there are like some solutions suggested in the proposal. And I guess there are some fruits from Barry in the article on how to address it. But so, yeah, the thing is that in C# and Rust, I guess, the access to the underlying enumerator or iterator or whatever is provided based on the count check. And while in C++ and D, on the contrary, the underlying iterator is actually incremented even if we decrement count to 0. And that's actually a huge difference. And so, yeah, there might be these corner cases, these issues with this final, step of the iterator. So let's see what the committee says on the proposal and how they like finally decide to address it. But anyway, it's interesting to read through the Barry's blog post to understand where the problem originated and how actually the C++ and D now different from C#.
Yeah, and I think there was a paper from a few years ago that covered the same ground. I forgot to make a note of the paper number, but I'll put it in the show notes. And I think there wasn't actually a conclusion to that in the end. It was never really solved, but there may actually be some problems if you do something different depending on the iterator type, which is what would really be proposed here. Like sometimes it would do n, sometimes it would do n-1. There may be things that rely on it doing it consistently. So forget the details, have a read of that paper when I post it in there. But I'm also not entirely sure whether it completely matches up here, whether there is something we can do differently. As far as I can see, it's not been discussed in depth on the committee just yet. So as you say, we'll see what they come up with.
Yeah.
Interesting problem anyway.
Yeah, let's wait for their solution.
Yep. Off by 1 error is one of the two biggest problems in computer science. We won't go into the full joke. But talking of iterators, Alfred Dwyer has something to say about them as well.
Yeah, let's iterate to another article here about the iterators, and that now about the concentrator. So Arthur made an interesting discovery about iterators. So like in the Astel, it's somehow guaranteed that iterator is convertible to concentrator. And this implicit conversion is implemented differently in lib C++, lib stud C++, and versus Microsoft Astel. And that's what the whole article is mostly about. So he's like discovering these differences. So in the first case, converting constructor is used, and the Microsoft case, there's a base class conversion used. And that's a huge difference because actually that affects the case where there is implicit conversion sequence. Because like you can't, apply more than several user-defined conversions. So yeah, there might be differences in the whole, how the whole code is working for you. So there are a few examples in the article, so you might check them and to see why that all happened. So like there are some references, I guess, to Microsoft implementation, and maybe there are even some reasoning behind that. I honestly haven't checked that in much detail, but there is some explanation about why that's done that way. So that's just an interesting article again to check about how these stud libraries are actually different. So because you quite often think about the stud library as just a whole, but it's actually not, as like it was mentioned at C++ Now talk on the stud library evolution. Actually, there is no one stud library. There are just this notion of stud library and several implementations which we have. And sometimes they do behave quite differently. For example, like in this case with the const iterator. So that's just one interesting difference spotted here, but I think quite important just to understand when you think about these stud libraries. So what do you think about it? Well, any words here?
Yes, I think the moral of the story is, as ever, if the standard doesn't say how something should be implemented and gives the library a degree of freedom, you should never assume that it's implemented a particular way, even if your particular standard does it one way today. And of course, that is much easier said than done, especially when things are not obvious that there may be more than one way to implement it. I think it's quite reasonable to make an assumption about this, which turns out not to be true. So, yeah, that's C++ for you.
Yeah, actually, there is one more third which I kind of stopped for a while to think about it from Arthur on the blog post, is that like the Microsoft style, they are doing this base class conversion, and he says that like this public inheritance should be used only for is-a relationship. Microsoft just kind of violates the principle here, so maybe that's why they run into this kind of difference with others. So that's kind of, some subjective word, but it has some reasoning behind. So yeah, maybe he's right. Maybe that's how it shouldn't be, but just to consider. Yeah. Okay, I think we can move forward to a little bit like another piece of kind of basic but very, very practically useful article, and that's how usually the Jonathan Bakar's blog looks to me. Always very, very practical advices, and always I like the fact that he's following the questions from the audience and, writing the articles on these questions, like experimenting with the questions. So you can actually ask Jonathan quite a basic thing, or maybe just, some simple stuff. And then you get a very interesting deep dive into how you can do things in this or other way. And this is one example of it. So just the question is very easy, like how to return several values from a function in C++. Like, first obvious solution is actually definitely not good. Is just, to put them to the output parameters for the function. That's definitely not good. So it violates many general guidelines and principles. The article is focusing on improving with, using std pair and std tuple and some improvements around that, and how to improve the copy overhead. So how to first of all, how to make less copies, but at the same time, keep the code kind of readable and self-explanatory. So you don't have, some weird code in the function bodies. So so the solution is there in the article. It's quite basic. So you just use an std pair or std tuple. And on the call sides, the values are retrieved using the structured bindings, for example, or std if it's C++ 11, because structured bindings is just C++ 17. So yeah, also there is an interesting question raised in the end, is about typical errors when returning values of the same type. And if you mix the order and you might not notice that easily. Definitely some says that you should have the proper naming, and that's one solution to that. The other says that you should use the strong types. That's the other solution. So there are kind of two camps of how to do that, and both, I guess, have their pros and cons. So you can check it. Actually, talking about the proper naming and how you can swap the things with the same name and how you can detect that. I remember there is, again, this nice Google paper on how help detecting parameters swap if the proper names for the arguments and for the parameters are used. So you can actually, write some logic which will be checking this automatically depending on the what are the names for the arguments and parameters. But again, to achieve that, you still have to, give your arguments and parameters some reasonable names, which I don't think we do all the time. Let's be quite fair here. So but anyways, so that's a good thing to check if you ever heard about this problem of returning several values from a function in C++.
Yeah, I think it's a excellently written article, and even if you do consider yourself an expert on C++, it's worth a read, because sometimes we forget some of these details. Covers pretty much all the bases except one, which I'll come back to in a moment. But one thing that really struck me about this was that all of these facilities that we've got over the years in C++, and most of them are enumerated in there, pair and tuple and structured bindings and RVO and all of those. And you think, now that the modern approach would be the best, but actually it turns out that the best approach that covers all the bases the best is just return a struct, and we could do that in C.
Yeah, That's true.
Some things come full circle. But the one thing that I thought was missing, which was, a nitpick, but an important one, is that the difference between passing something in by reference as an out parameter and actually returning it, and assuming an RVO applies, is that in the first case, you have to potentially pay a cost of initializing and then be overwritten. So you've got that like two-stage initialization problem going on, which can be quite costly. Or you could leave yourself open to, uninitialized variables, which are going to be even harder to track across function call boundaries. Whereas when you use RVO, return value optimization, it's as if you have passed an uninitialized copy in, and then it fills it out using initialization rather than assignment. So you get the best possible performance and the best possible safety. So that was worth pointing out, and I think that was missed in the article. As if you needed any more convincing not to use out parameters.
Yeah, I was actually waiting for Jonathan to put this proposal from Herb on the table with, marking all these in, out, forward, move parameters. And I was, to be honest, waiting for this link till the very end. And I was very surprised that I haven't met it there, but maybe just because that's not in the language, actually, it's just the proposal, which still sounds quite interesting, and promising in that sense. So maybe we can put some, logic and semantic when we have these parameters explicitly marked as if that's an output parameter or just an in parameter, and we can do something in static analysis and in compilers, then it might help.
Yeah, but then we'll still have the syntax that doesn't require it as well, so it won't help in all cases.
Yeah. Yeah,
and in new code, you should generally try to avoid them anyway.
Yes.
But very rare you really need it in out parameter.
Yeah, nothing is a silver bullet. Yeah, that's true.
Yeah. But talking of performance, what about parallel STL algorithms?
Yeah, I spotted that this month that Rainer Graham actually did a couple of posts talking about the parallel algorithms of STL. So the first one, not this one, but the previous one, was mostly describing the basics of what are these execution policies in C++ 17. So what is this sequential, when it runs obviously sequentially, execution policy when there is a parallel execution, and execution policy which occurred vectorized. So when the code is running in parallel on multiple threads and allows this kind of interleaving of the individual loops, and it works nicely for SIM, the single instruction multiple data. So the first blog post actually explains all these basics with some code examples. But this one then is presenting the measures which Rainer took to test actually the parallel STL algorithms, and the idea was just to understand if actually using them brings the benefit, and what is the actual benefit. So will it be 4 times quicker if I have 4 times more cores on my system? And it's actually how it goes. So that's how it works. So he actually proves the idea. So he was doing the tests with Microsoft compiler on Windows and with GCC 11, I guess, on Linux. So he kind of took, for Microsoft compiler, it was also some recent versions. So there were just the 2 recent versions on Windows and GCC on Linux. So, and the results were kind of just as expected. So on Windows with 8 cores, he got the parallel execution something 10 times faster than the sequential. And on Linux with the 4 cores, he got the execution 4 times faster for the parallel case. Interestingly, the parallel and the vectorized case are very, very comparable. And it seems that the thing is that Visual Studio implementation of the parallel and vectorized policies are just nearly the same. And actually all these, the differences between parallel and vectorized is just a hint for the compiler. So the compiler could probably just default to parallel and that's it. So that's why probably the numbers are comparable. So that's just also a very interesting observation. So yeah, that's just a short article that proves that actually the whole idea generally works. So if you ever considered but still questioning these parallel algorithms, probably you can start using them, because you will likely see the real benefit, and the benefit will be just just as much core as you have, you'll get this benefit. numbers will correspond. So that's actually good to know that, the idea proved itself. So yeah.
Yeah, absolutely. And I guess we moved more and more into the multi-core world. Obviously, we've been in for quite some time now, but increasingly now the heterogeneous world with GPUs and other external chips that can really speed things up massively. The parallel STL algorithms are a very specific way of doing that. We do need a more general mechanism for being able to deal with parallelism and async in particular. And of course, that's been the domain for many years of a concept called executors. So that's a good lead into the standards news, because there's a new paper just arrived, P2300. So it's on R1 now. Stood execution, and this is continuing the story of executors. It's not an executors paper though, which is interesting. But yeah, this sort of supersedes the previous one, unified executors proposal, P0443. That was on R14 just recently, but the first version of that actually dropped in 2016. That paper alone has been around for a while. That was the unified one. That suggests that it unified some existing proposals from even before that. And I think I traced back the earliest one that directly contributed to that to this one from 2012. So nearly a decade we've been trying to get executors into the standard. And of course, even that was based on earlier work. In C++11, we got stood future and stood async, which, they're an attempt in that direction, but they have some problems, particularly performance, dynamic allocations, and even just composability, the way these things work together when you start to put them together in different flows. So that and other reasons, particularly for heterogeneous computing, as I say, that dynamic allocation cost was a real killer. We started going down this road of executors, but turned out to be a bit tricky to get right. So we're still at it. So rewinding back to this latest proposal, what does it do differently? So it's actually quite interesting to look at what it's not. It actually starts off the paper, what this proposal is not. So it's not a patch on top of that unified executors proposal, and not asking to update the existing paper, but retire it in favour of this new one. And then it goes on to talk about, in the second paragraph there, takes the design of the current executors paper, that's the unified one, applies targeted fixes to it to allow it to fulfill the promise of the sender-receiver model, as well as all the facilities we consider essential when writing user code using standard execution concepts. So it's taking all the feedback that they got from SG1, but then also sort of reframing it in terms of this, what it calls the sender-receiver model. Now, I'm not familiar enough with any of these papers to really be able to do justice to a comparison between sender-receiver and what we called executors before, so I'm not even going to attempt it. But it is a slight difference in direction, which, still has the potential to displease some people. But I think the idea here is to try to really strip things back to some sort of lean and mean, like a minimum viable executors in a way, except it's not executors. And I think we also discovered that this sender-receiver model probably addresses more of our needs better anyway. It also lists all the design changes, which is mostly the SG1 feedback. So there are quite a lot of fixes that have gone in, as well as things that have come out from compared to the executors paper. One question you may have, and particularly if you look at some of the early examples, is how does this compare to coroutines, which we already have in the standard now? It looks like some of those examples will be better written as coroutines with a bit less syntactic noise around them. But coroutines themselves also potentially have this dynamic memory overhead that we can't really afford to have. And they don't tend to play very well with the concept of cancellation. So if you do need to do an early return and then communicate that to the mechanism that's making it all run, it's not impossible, but it's very tricky to get right. You have to be really careful about it. So this is sort of like a little bit more bare bones. You put together the sequencing yourself, so you're in control of it. And then the cancellation facility is quite well defined. Again, I'm not going to say more than that. I'm not familiar enough to do it justice, but that's my reading of this. Seems like a good step. Whether it's going to be enough for everybody to agree in time to get it into 23 seems a bit tight, but I know some people are hopeful. It seems like a decade is long enough for us to actually get something in the standard in this direction.
Yeah.
So we definitely need it. So did you have any thoughts on this one at all, Anastasia?
Yeah, I'm actually impressed with, 14 revisions for the original paper and that many people involved. And I see some names who are definitely very, very interested in in this paper. And actually, I see some interest and I see some discussions now in the community about the executors and how we might use them, how we might benefit from them. So there is some, I would say, expectations for this. So not sure. Let's see how it goes. Maybe it will require another decade, but hopefully not. Let's see if starting not from scratch, but from some kind of a new paper will help us here.
Yeah, I'm hopeful we'll get something, as long as it doesn't mean that we get the wrong thing. That's something that we have had to do before. In fact, talking of that, the next paper to look at is a contracts paper. So contracts famously were taken out of 20 after they were initially accepted in. And since then, we've been keeping an eye on this. We've mentioned this a few times in the show. Some papers have come out where it's not a new contracts paper, but it's talking about things in the space, trying to pin down all the terms used and what the interesting use cases are. It seemed like we'd had differences of opinion on those before, differences of understanding even. And that was what was really getting in the way of achieving any sort of consensus. So this is the first one, at least that I know of, that's actually a new contracts paper. And similar to the not executors paper that we just looked at, this is sort of stripped back even more so than the stripped back version that made it into 20 originally. They've taken out the things, anything that smells of being controversial. So it's called Abort-only contract support, because one of the biggest controversial points was this idea of continuation, where if a contract handler is violated, or the contract violation handler is called, there is a mode where execution can continue regardless, and that leads to all sorts of problems with undefined behavior. In fact, introducing undefined behavior that wouldn't be there without the contract, and allowing this time travel problem that I think we've discussed before gets very messy. So you can understand that being controversial. So that's just been taken out. Yeah? It's not in there, so it's not a problem. So this is really very minimal. It's just either the contracts are not considered at all, as if they were not there, like there were macros that were compiled out, or they are checked and abort if they fail, and that's it, really. Syntax is basically the same as the contracts paper that was originally accepted in. In fact, most of the details are, apart from the things that have been taken out. So it seems like it has a good chance of making some progress, I think, because there was obviously decent support before, just not quite enough. So taking out those controversial bits, I'm hoping is going to be enough to get something in for 23. We thought it might be too tight. Maybe it still is, but this is probably our only hope. So let's hope that it doesn't get aborted. Any thoughts on that?
I guess everyone was hoping for contracts in C++20, and there were these sort of, big fours in C++20, which actually turned to be big threes. Mm-hmm. I mean, modelless concept and coroutines, but I met many people who were still thinking the contracts are there for quite a long time, even though they were stripped out kind of at the very last moment, I would say. So, at least many people even didn't notice that on time. So hopefully we'll get them sooner or later. From the tooling perspective, from the company involved in tooling, I'm still thinking that all we need is just to understand how it's designed and what is the syntax, and then we can try and help people with some static analysis on top of that. Mm-hmm. But first, the committee has to, agree on how it actually planned and how it actually intended to work. So, like, define this, minimal scope, or MVP as they call it. It's actually interesting to see this, operation in the language proposal. But like, if we got something, we can start working on that. I mean, add into some compilers and add into code analyzers. So that would be, I guess, a very good move forward for the developers. But first, we need committees to somehow decide what are their goals with the contracts. I guess that was the main point for the arguments. Like, what are the goals? So how we all see them. So hopefully that will be resolved. Let's see.
Yeah, absolutely. And another topic that's well, this is not going to make it into 23, but it's good to see still a lot of discussion on it as we move through that time frame. Is pattern matching, but this is a new paper from Herb Satter. Pattern matching using is and as, and it's a pretty big paper because it pretty much subsumes all of the previous or current pattern matching proposal that's being worked on, but with some very important twists. As the title suggests, it introduces two new keywords, the operators, is and as. And if you're familiar with some other languages like certainly C#, and I think some others have these keywords, they use them pretty much just as dynamic casts, or tests involving dynamic casts. And these can do that, but they're much more general. In particular, they are overloadable operators, so you can actually plug in whatever behavior you want. And even if you don't do that, there's a whole series of or sequence of different ways they can be used that are well defined in the paper. So you get all sorts of very nice behavior just out of the box. It looks quite complicated when written down, and maybe that is a problem, maybe that's not. But in usage, it just does seem to give us some very nice properties. In fact, just to show you one of the Tony tables of the existing pattern matching syntax versus the Herb's proposal, there are some consequences, and one of them is that one of the problems that keeps coming up with the existing pattern matching proposal is this ambiguity between when a name is mentioned. Does it mean a newly introduced name that binds to some part of the pattern, or is it a reference to an existing variable? And so we've had to introduce things like either the case keyword for the existing name or the let keyword for the introduced name, which is all fine, but it does make the context, the syntax sometimes look a bit dense. So this avoids all of that by placing, well, when you have a decomposition match where this comes in, you actually need two square bracket blocks. One on the left has the names that you're binding, and the one on the right has the thing that you're matching against. And that still sounds a little bit ambiguous when I say it like that, but when you see it, actually it makes perfect sense because it's got is or as in between. And that's what makes it just read very naturally. I can see what's happening. So it solves that problem, but at a slight cost that, as you can see in the middle of that Tony table, it does get a little bit more verbose. Creeps across the page. But some other things are less verbose. So on balance, it's probably about the same. So that's very promising on its own. For me, I think the most attractive part of this paper is that these keywords can be used throughout the language, not just in a pattern match, not just in an inspect statement. For example, you can use them in just normal if statements, and they work exactly the same way, and they look very natural as a result. So that expands the power that we've really only had in pattern matching before to be used throughout the language. So don't know whether this paper in exactly this form is going to be what takes over, but I think it's some very interesting ideas. Very keen to see that discussion move forward as well. So I definitely have a big interest in pattern matching. Any thoughts on that?
Yeah, I would say that I'm looking now at that. I really like how the code looks on the right of the Tony table, like all this is. Just because, it reads easily. And that actually means, I can't stop thinking as a tooling person. That means that it's parsing easily, and we can do a better job. So, but yeah, readability is very important, I would say. So when you have something that's structural, you have these names on the left, and then you have what you're binding on the right. It's always much easier to parse and much easier to read. And I think that's what Herb is trying to do with quite many recent papers, is just to make the language, easily semantically readable. Like when you read the language and you actually understand the core concept behind this piece of code, and you don't have, to apply too many rules of what it actually means. So yeah, I think that looks like a part of this attempt.
Yeah, I think it's a good sign that it just works naturally in all these different parts of the language. It doesn't need to be in a particular place for it to work. So that's a good sign.
But I would expect some people who would say that this is not a real C++. Yeah, but that's fine.
It's definitely not real C++ 20.
Yeah, that's true. That's true.
Okay, moving on, got one more proposal to discuss. So we've had a few big papers already, and this is another big one on modules. Actually, it's not such a big paper, it's just a big topic. So I mentioned earlier that we were going to talk about modules again. Obviously, they're in C++ 20, but as well as all the problems with compilers not supporting them, the tooling not being there, there's still some issues, particularly around our expectations on tooling and what we can say about that are still unresolved. So around the time that they were still being put into 20, there was a new study group started, the tooling study group, and one of the things they were given was this project, if you like, to create a TR, technical report on tooling around modules, the ecosystem report, I think it was called. And they were given a number of questions to resolve, to provide recommendations for tooling vendors to be able to establish a consistent way of working, so that where possible they can interoperate, or at least work with no surprises. And that seemed to have gone a bit quiet a bit. I don't think a lot went on there, particularly during the pandemic times, but it seems to be picking up again now. And so this paper has come up in that vein. It doesn't seem to be particularly targeting that TR. In fact, it seems to be suggesting a new one. And I'm not sure if that's just because the author didn't know about the original one, or because the original one didn't go anywhere. But it does present a number of requirements, as the title says, but not just for Bloomberg. That just happens to be what the author knows about, but they're pitched as being more general purpose. In fact, really for anyone that doesn't use a monorepo, I think is the idea here, which is probably most companies or most projects. So the set of requirements, there's 7 of them. They're mostly to do with dependency discovery or module discovery. That's always been the big sticking point. So there's a set of requirements that these people at Bloomberg feel are really important. And they do have impact on different types of tooling, and static analysis is mentioned in there a few times as well. But I think when I first saw this, I was a little bit worried that some of the big problems that we talked about back in the C++ 20 timeframe maybe hadn't been resolved as well as we thought. But I think that they have. They just hadn't necessarily been accounted for in this paper. So in particular, the parsing overhead in order to discover what a module's dependencies are is not a full C++ parser. Just need a preprocessor. But you can't do it with anything simpler than a preprocessor, because it does need to be able to do preprocessor substitutions in order to work out what a module is. So I think some of the concerns maybe are not as big as they seem, but good to see that these are being picked up again. I would have hoped that most of these would have been more resolved by now, since C++ 20 is already out there, but I think it's good that we're continuing the conversation about it. Did you have any thoughts on this one?
Yeah, actually, I'm thinking about that. from one side, we have, this models featuring the standard, which is kind of signed, and we're like, 2021, we have the featuring in C++20. And we have some implementations even ongoing in the compilers and in the build systems, but nothing is actually really ready for all these production cases, like Bloomberg probably, just because, there's still some things to talk about, still some things to address, and a huge work for the tooling vendors to actually adopt all these changes. So while I might be impressed with 48% going to adopt models in the next 12 months, but I'm really not sure they will be able to do that, to be honest. Just because there's still a huge bunch of work ahead of us with models, and we need to resolve them very carefully, I guess. Otherwise, the models won't be really usable. So, and I guess the problem is maybe that sometimes the regular C++ developers, they might not understand how much work is still ahead of us. Like a very simple example, I remember people are just coming, to our tools and asking when we're gonna, roll out the support for models. And I was always wondering how you're gonna use that, because you don't have a project model which supports them, because I guess it's now only Visual Studio who can do something, and Build 2, I guess we discussed that in the past episodes. But apart from that, CMake still lag behind that, and others. And you think about, so we can do something in the IDE, for example, but you still don't have the proper tooling, and you still have, all this list of things to discuss. And I was following this mailing list with all these discussions about preparation for this report and all these things. And there are so many things were still not resolved about the model. So I'm just wondering when we're going to actually have the models. So should there be a language release with the actual models, when everything is ready? I don't know. Let's see how it goes.
Yeah. I'm not sure what else we need in the language. There may be things built on top of it, but I think what we have now is what we've got. It's this is more about recommendations for tooling and build systems.
Yeah, it turned out that the language part was very, very small. I mean, it was not that big. But to prepare the whole ecosystem for that is much harder.
Yeah. Yep, build systems are still the biggest problem in C++. So talking of tools, we have a tools section. So the number of new tools, or versions of tools rather, being released or updated or something this month. So I'm going to take us through with starting with Qt Creator 5.
Yeah, let's talk about some tools which were updated in July and some major milestones for them. So Qt Creator, it's just a better, not just a final release for 5.0, sorry. But I actually spotted a very nice change there, that they moved from the libclang-based code model to clangd-based code model. That was very interesting, because for a long time when we started implementing the clangd-based engine in CLion, we were also considering if we should do that on top of the libclang, like the Qt Creator is doing, or should we move to the clangd and implement some kind of language server protocol or something. And it's interesting to see that the Qt Creator, who were on libclang for quite a while, now is moving for the clangd. It's still some early stages as far as I got, because they said that quite many things are not yet there. But it's anyway interesting. The maybe only surprise here to me was that I guess they are on top of the just the major clangd branch, the main branch, while for libclang, I guess they had some own implementation, which they were not, sharing to the public. So I'm just wondering if they're gonna do some custom branch for the clangd as well, or they're gonna, do that on top of the main branch. But that's just, some technical interest here. So anyway, so they have some interesting change. So hopefully they are expecting quite a huge outcome in terms of the code model when switching to clangd. There actually one definite benefit here, because libclang is just a library. So if something is failing in your language model, everything is failing for you. I mean, the whole IDE. But with the clangd, which is like just a daemon, so if it fails, you just restart it and everything is fine. So you can just continue your work without any issues. And that's a good point, I would say. Like from our experience, that's a much more reliable approach here. Anyway, let's see how it goes for Kit Creator. They have some other news here, like some support for building and running applications in Docker containers, which you might be also interested in. But yeah, I was mostly like spotted this clangd fact and was really interested in how it goes for them. Yeah, let's move to other tools maybe. So yeah, CMake 3.21 was actually also released in July. I guess after CMake 20, which brought many big things like CMake presets and some like new compilers and some updates to CMake file API, this one is more like bug fixes maybe release. But I have to spot here that CMake 3.21 actually brings CMake presets version 3. And the thing is that, like, while in CMake 3.20 it was CMake presets version 2. And the thing is that they are not backward compatible. That's what the kitware states, that there will be no backward compatibility between the presets version. So when you change the CMake 3.20 to CMake 3.21, you actually have the new version of CMake presets, and you might have some issues if you just rely on some backward compatibility. So just be accurate if you switch the release. So also among the other news, there are some new generator for Visual Studio 2022. Which is now the preview. And yeah, talking about this Visual Studio, actually, they announced the hot reload updates, and especially interesting fact for C++ developers that they now have hot reload for C++. This, I guess, a great thing when you would like to, to shorten the loop when introducing some code changes, when, prototyping or debugging some application. So, and you don't want, just the regular loop is that you spot an issue, you stop the execution, you introduce the changes, you build everything, rebuild, and then like launch the debugger again, go to this point, try to check that everything still works, and the bug is fixed. And with the hot reload, you can actually introduce the change and then ask to get this change into the working binary for you under the debugger. And so it injects the changes into the app dynamically, and doesn't trigger full rebuild of the app, which is actually great. It works for MS Build C++ projects and Visual Studio Debugger only, but that's kind of expected for the Visual Studio tooling. And I think they are planning this for CMake applications later as well. And so yeah, they're sharing this news on the feature and also collecting the feedback on the feature with some surveys. So if you're gonna try the hot reload, just make sure you also share your thoughts in the survey with the Microsoft Visual Studio team. Talking about the next thing and the IDE here. So definitely my second activity, big activity for this month was the CLion 2021.2 release. So yeah, it's actually this release, I would say it's aligned with the most recent changes in the C++ ecosystem, definitely. So we were very much focused on the recent additions. So like first thing is the CMake presets. So I would say that I was capturing the video and it just, nicely works. So if you just get the project with the CMake preset, you just open it in CLion and the presets are loaded for you. So you don't actually have to do anything additional. It's only works with the version 2 of the presets for now. I guess we will be introducing the version 3 in the next release. Again, as I said, they're not backward compatible, so just be careful with that. But I think CLion will throw you an error if you try to load the presets of version 3. There will be some notification. Also, like there are this thing called lifetimes analysis. So that's based on the Herb's proposal about the analyzing, like catching object lifetime issues. And the good thing is you actually don't have to wait till Herb's proposal is in the standard and till the compilers are actually implemented it. So you just can try CLion and check these code analysis checks just in your IDE. There are like many updates to the debugger, especially for the Windows users. I won't list them all, so you can find them on the website or in the blog post, but I would just say that quite many things done for Windows debugger, especially for Microsoft toolchain, and like lots of overall improvements for the breakpoints configuration. And also we actually taught CLion to work with the AutoTools projects. So the make files were there before, but we just added the support for the preconfigure tab. So now you can just open the AutoTools project. CLion will execute the preconfigure tab automatically and load the project for you. So yeah, there are many other things there, like the Clink interpreter bundled. So yeah, and if you haven't heard about it, there is actually an interpreter for C++, which you can take and play around with. And like, yeah, many other things there as well. So all the news are on site and in the blog. And so you can go and check and grab the free trial and give it a go. And let us know what you think, actually. We're very much interested in the feedback. And yeah, I guess that's mostly it about the
bit
tooling.
that I was most interested in the CLion release was in your and many other things section, and that was the the new Docker support, or at least a step in that direction.
Yeah, so
I think previously you had to set it up just using the remote toolchain and have files synced into a container, whereas now my understanding is you properly support having the files locally on a mapped volume.
There is a mounted folder for the Docker container, so you can actually change now the connection type in CLion, saying explicitly that we'll be using the mounted folder, and then it means that CLion will skip this code duplication step when it just copies the code, and so yeah, everything will be like working maybe a little bit faster in terms of these redundant copies will be removed from workflow. So yeah, there's just I put it to these small other things, but I realized that it's quite important for quite many people, I would say, who are relying on these workflows. There are actually quite many important things in these other section as usual.
Of course, yeah. Just that was the one I was most interested in.
Yeah, good to know you find something there for you.
So finally, then, what's this about, Bjarne?
Yeah, actually, as I said, the most interesting news were coming by the end of the month. So it was released in the end of July. The nice interview with Igor Bogan and Bjarne Stroustrup. So the interview is it's funny thing. It's exactly 1 hour long. I guess it's 59 minutes something, but it's really nearly 1 hour long. A very nice timing, I would say. And it covers many quite, I would say, global and deep questions on programming languages and goals and evolution of the languages. So they talk about the Bjarne's vision for C++ and about his goals for C++. So the questions there, they sound sometimes very, very, general. Like, for example, Igor is asking about how to make a language popular. And there is a very nice answer, I would say, from Bjarne, which I really liked, is that the language has to solve a problem, not to make a statement. So there should be this goal for which the language is actually created, and you should actually serve this language in a long timeline. So there should be this persistence on language evolution. So I would say I really like this idea of the goal for the language, because I always think that every language has its goal. I don't believe that there are just languages which are created for the sake of themselves. So, yeah, and I also liked actually their discussion on the no-code trends and IE trends for code improvements and refactorings. I think that was I was in the university when I heard for the first time these discussions on automatic code transformations and IE actually writing some code for some visual models, whatever. And will these things ever, substitute the human beings in the future? And we won't need any, programmers. And Bjarne says that, yeah, IE is actually good at looking at abnormal behavior. That's true. You can, you can do some tasks like the code checks for the artificial intelligence, but it's still very local, and someone has to think about the overall, the global structure and architecture. That still has to be some human being. And also with the automated refactoring, like there are some strong guarantees needed. Like we have, for example, these, MISRA guidelines, which we have to follow for the automation. And if we, redirect all our, refactorings and some code transformations to the AI tools, to the robots or some automation, we still need something that will prove that the code transformations are still, correct, and the we got from what we start actually semantically, and the things like performance criteria are taken into account. So yeah, Bjarne is actually discussing all these points, which are kind of essential if you talk about this, AI algorithms for code transformations. So yeah, it's a very interesting interview. It's not diving into that many stuff on like technical questions on C++. I guess they're still discussing the very popular question to Bjarne, I guess, like what would you change in C++ if you get a time machine? And I really like his answer that he would better bring a better machine, to do the stuff, because as he said at that time, so all his ideas he could have now, they won't be possible at the past. So he just didn't have that resources. So if he actually could have a time machine, he would take some, better actually machinery there, so to implement these things. And he explains this in many details. He said that he would, in the past, he actually was thinking about all these outer and concept ideas, but that was not a proper timing for them at all. So you just couldn't afford them at that time. And now there is much better timing for that. So yeah, just a very interesting interview, I would say, in terms of some global firsts. I don't know, Phil, have you spotted everything interesting in the interview for yourself?
I've only seen that single frame so far, so I can't comment on this specific interview, but I just will say that anytime you listen to Bjarne talk, particularly about C++, it's always going to be interesting. So I would encourage you to watch it anyway.
Yeah, actually, there are quite many interesting firsts, and I would say quite many hot topics from the C++ community covered in this interview. Like Bjarne was asked if it's important to design a simpler language when you still is trying to do a powerful language quite often. Like in C++ case, you get kind of complicated language. It's not that easy for the beginners to start with it. But the answer was that the solution is not necessarily in the language. The solution for the Bjarne is have the core guidelines, like the C++ core guidelines, that have some minimum set of libraries to support these guidelines, and then has the code analysis to force these guidelines. So that's not necessarily should be a very simplified language. So sometimes you can't get it for the goals you have. And again, that's about the language which has its own goals. So yeah, that's just an interesting first. So if you would like to understand, how this whole evolution goes in the head of the main creator, you'd better check the interview.
Yep. And like you said, that interview ran for just under an hour. We've blown way past that, so I think we should wrap up at this point. So thanks for making it this far, and I'm sure we'll have even more next month. So until then, we'll see you next time.
Yeah, see you. Bye.